Next topic is combination of cells. First one, cells in series combination. Here you have to consider two cells. The two cells are connected in series. The EMF of the first cell is taken as E1 and the internal resistance of the first cell is R1 and the EMF of the second cell is E2 and the internal resistance is R2. Let I be the current. Here we have to calculate the potential difference between the terminals of the first cell. To calculate this, we have to use the equation terminal potential difference V is equal to E minus I into R. So the potential difference between the terminals of first cell, we can just write VAB, which is equal to EMF E1, and in series combination the current is same, so that we can write I into R1, that is the potential drop in the first cell. And next we have to write the potential difference of the terminals of the second cell, can be written as VBC, which is equal to E2 minus I into R2. Here E2 represent the EMF of the second cell, R2 represent the internal resistance of the second cell. Next we have to calculate the potential difference across the terminal A and C. Here we can write potential difference across the terminal A and C, which is equal to VAB. Potential difference across the terminal VAB and the potential difference across B and C, that is VAB plus VBC. Here we can write VAC is equal to E1 minus I into R1 plus E2 minus I into R2. You can write E1 plus E2 minus I into R1 minus I into R2. The same equation we can write E1 plus E2. Here we can take minus I as common. Then we will get R1 plus R2. And this E1 plus E2 is said to be E equivalent minus I into R1 plus R2 is equal to R equivalent.
If you found this video helpful, please like, share and subscribe to the channel. See you next class.